We're gonna build an example black oil PVT model using PVT Solver. And this is the interface of the software. By clicking options, we'll set up the model. First of all, we need to select the fluid type, whether it's black oil, dry gas, or wet gas. So in our case, we're gonna select the black oil. As you know, the gas oil ratio of black oil is initially 1500 SCF per stock tank barrel or lower. And its solution gas is classified as dry gas. Therefore, dry gas calculations are applied as well when you select the black oil. And then formation water, regarding the formation water, as per example, it has been detected. So we can click here. Fluid composition is not known, and laboratory data are available. So now we can click on data. Here we go. Input data for the oil gravity. Let's clear it all. Input data for the oil gravity, 19.45. Gas oil ratio, 259. Gas gravity, 0.711. From here. Sorry. Okay. Okay, nitrogen is 0 and salt concentration is 187. Here we go. So we have just input our field data for a single stage system of separation. By the way, the single stage system of separation assumes that no additional gas is separated from the oil in the stock tank. However, the two-stage system accounts for the amount and properties of the stock tank gas. So in our case, it's a single stage system of separation. By clicking on lab data, let's clear it all. We would need to input our laboratory data. So in our case, we're gonna use the preset data, and we are going to input solution gas oil ratio, oil formation volume factor, oil viscosity, gas viscosity, and gas formation volume factor. So let's use the preset. Here we go. Here's the preset. Pressure ranges from 3000s to 100s. Here's the pressure. And here's solution gas oil ratio. You can see it here. Automatically plotted. Here it's viscosity. Here's formation volume factor. You can also display the dry gas properties, formation volume factor of the gas plotted, and viscosity also plotted. Bubble point pressure, 1960. This one, constant versus pressure, as usual. By clicking match, select all. By clicking on match tab, you will have the opportunity to match all your lab data in order to minimize the mismatch between laboratory or experimental data and simulated data. So that's how the interface displays. You got A and B. A is the multiplier, matching modifier multiplier, and B is the shift to the model or the correlation. So one click on match all will definitely at no time will make the correlation almost the same as the observed data. So as you know, all the values for A and B are already modified, and that's how it's very efficient in order to match your model to lab data. Very efficient and very quick. The third step is to select the optimum or best fit correlations by clicking best fits. the software automatically selects the best fit correlation based on the minimum mismatch between the observed data and correlation. Now let's do the same for the dry gas. Properties are plotted. Simulated data versus lab data. For example, gas formation volume factor is calculated using DEC, Hall, and Brill, and gas viscosity is calculated using Lee, London, and Sutton. 3 correlations here and 3 correlations there. By clicking Match All, let's get closer to it. By clicking Match All, the correlations are tending to get closer to the observed data by changing A and B. A is the matching modifier multiplier, and B is the matching modifier for the shift. Okay, you can see it here. Select all, reset all by one click. Example. By one click, all correlations are tend to get close to the observed data by changing A and B. Okay. So dry gas now. Let's select best match. Dry gas best match. That's why all properties are matched for black oil and for dry gas. By clicking calculate, you can calculate any property using any correlation, but the automatic correlation selected is the one with the minimum mismatch error. So that way you can calculate from 500 to 5000, bubble point pressure, solution gas oil ratio, formation volume factor, viscosity, density, isothermal compressibility, total formation volume factor, gas oil interfacial tension. All PVT properties are calculated. Dry gas as well, calculated. All water properties calculated. By the way, the water properties are calculated using 2 authors or 2 correlations. IAPWS, which is more reliable and more efficient, and McKean correlations. All correlations are calculated. Okay, you can display untabulated data. For example, you can display black oil data. Let's make it 20, 500, and 5000, for example. So the bubble point pressure is calculated using the standing correlation with these matching modifiers. The RS is calculated using lasso with these matching modifiers, and this is the best fit correlation for the RS, and so on. Now, what if we stop or not validating the model with a specific lab data? There will be a huge difference in results. So inputting lab data and validating using lab data is very, very important. So if you get back to options and click on not available lab data, then click on data. Let's use a preset, same preset, and calculate. Back to field data, you'll see that a huge difference in the bubble point pressure. Some correlations, 2000s for example for Valco, and 2600s for Glasso. 600 psi difference between the minimum and maximum, and that's why we always recommend to use matching data or input your lab data in order to validate and calibrate your black oil model. So there is a lot of correlations to apply But the question is, what is the best fit correlation for your model? And that's why we always recommend using lab data. So you can see the difference here as well. Viscosity. One more thing is you can apply a specific bubble point pressure. For example, you can, if the district engineer in the field could identify the bubble point pressure from production data, and say it's 2075. So in that way, the software allow you to input a specific value for the bubble point pressure. And that's why all correlations will follow that value and apply it. Okay. In that case, you can calculate other properties independent on the value of the bubble point pressure because it's already as an input. Then that's very, very efficient approach in order to minimize the uncertainty of your model. One more thing, what if you have a two-stage system of separation? If you have a two-stage system of separation, you would need to identify the properties of stock tank gas, and if the properties of the stock tank gas are not known, you would need to input your separator conditions. So actually you have three scenarios in the case of the two-stage separators used. Two-stage separator means that more gas is separated from the stock tank, and that's why you need to input whether properties of stock tank gas, that way, oil gravity from the stock tank, gas-oil ratio, gas gravity, and separator, gas-oil ratio, gas impurities, and gas gravity. And if the properties of the stock tank gas is not known, you would need to input the separator conditions. Here we go, which is temperature and pressure. This is the difference. What if you don't have even neither properties of stock tank gas nor separator conditions? The software will use a correlation in order to account for the more gas that has been separated from the stock tank. So you can also use that case. So you have three scenarios when applying two-stage system of separation. You would need to identify based on your input data available. You can change units here as well. You can use field units or metric units or even custom units. You can select manually the system of units that has been used in your field. You can filter here between gas, oil, and water. Okay, let's back to the field. You can also display all reference correlations, all used correlations sorted by the fluid type in use and the PVT property, bubble point pressure, solution gas-oil ratio, formation volume factor, and so on for black oil, dry gas, and formation water. Dozens of correlations has been embedded into the software. Here is user guide for any help, support. You can follow the steps here as well. Very clear, very straightforward. So to cut it short, in summary, I would like to focus on the features main model setup here. You have three fluid types. You have the option to input your fluid composition in order to create more representative fluid model. You have the option to input the formation water salinity to account for the properties of your aquifer. If your lab data is available, it's recommended to input your lab data in order to calibrate your model. And that's it. Thank you so much.